Hi there. I'm going to go over a few examples of adding and subtracting rational expressions, and then we'll take a little look at complex fractions as well. So first of all, if I just look at numbers, when I add or subtract fractions, I have to have a common denominator. So if I have 3/10 plus 1/10, I add the 3 plus 1, and I get 4/10. And if I can simplify that, I will. And in this case, 4/10 simplifies to 2/5. So let's look at rational expressions here with variables in them. I have a common denominator, so I can go ahead and put down my common denominator, and then on the top I've got this quantity plus this quantity. So I've got 2x plus 1 plus 5x plus 3. Now we know that when we add polynomials, these parentheses don't affect how we combine our like terms. So if I have 2x plus 1 plus 5x plus 3 over my common denominator of x minus 7, I'm going to clean up the top, and I get 7x plus 4, and I still have it over my common denominator. You don't cancel the x's, you don't cancel the 7's. You never cancel part of a factor. Anytime you have something that's hooked to another term with a plus or minus, it either all stays or it all goes. So that's my final answer. So now let's take a look at what happens when the denominators are not the same. Okay, these denominators are not the same, so we need to get a common denominator. Now we've spent some time already this year looking at how to find an LCM. The LCM stands for least common multiple. That's the same thing as LCD, least common denominator. So the smallest number that both 6 and 8 will go into is 24. So when it comes time to add these fractions, I need to multiply both fractions by 1 in the form of something over itself. And the number that I choose is the number that makes my denominator 24. So for this first fraction, I need a 4 to go with the 6, and I have to put the same number to the top and the bottom. For the 8, I need a 3. So for this first fraction, I get 20 over 24, and for the second fraction, I get 9 over 24. Now my denominators are the same, and I can just add the 20 plus the 9 and get 29 over 24. So just remember that this number is really a 1, and this number is really a 1. Anytime you multiply by something over itself, that's 1. So I'm not changing the value of those fractions, I'm just changing the way they look. Now let's look at one that's a little more complicated. Okay, let's look at this problem. These denominators are not as easy to just look at and make a guess at what the LCM is. So we need to go back to what we learned earlier in the year, where we break down each of these numbers down into their prime factorization. Then for the LCM, you go to your first one and you write down every single factor. So I've got a 3 times a 2 times a 2. Then you go to the second number and you look and make sure all 4 of those are up there. This says I need a 2. Well, I've already got one. It says I need a 3. Oh, I already got one. I need 2 more 3's. So I'm going to write 2 more 3's up here. So if you look, the ones that I have underlined in blue make up 54. The ones that I have underlined in red make up the 12. Hopefully there will be some overlap so that the number isn't just 12 times 54. And when I multiply all of these numbers together, I get 108. So that's my LCM. So now when I come over here and I need to get my common denominator, I'm going to multiply 12 times 9. So I'm going to put a 9 over 9. And 54 times 2. So I'll put a 2 over a 2. So what I end up with is 9 over 108 plus 30 over 108. So altogether I get 39 over 108. Now I need to do one more thing. Whenever I have an answer that I'm going to leave as my final answer and it's a fraction, I need to make sure that it's simplified. Now I know there's a common factor of 3 and 39. I wonder if 3 will go in here. Well, let's see. So come over here to the side, do the little division, and see if 3 will go in there. It goes in there 3 times, subtract and get 1, bring down the 8, and it goes in there 6 times. So it looks like I can divide the numerator and the denominator by 3, and what I end up with then is 13 over 36. That's as simple as this one can be, so that would be my answer. Okay, let's jump into a problem that has variables in it. These are two rational expressions. Now, we're going to do the same thing we did last time. I've got two denominators here, and remember that this is one quantity and this is one quantity. So when it comes to finding the LCM, I'm going to do what I did in the last problem. I'm going to factor these so that I can have a better idea of what I'm working with. So for this first one, there's a common factor of x. I always look to pull out the common factor. For the second fraction, that's a difference of squares. So that turns into x plus 2, x minus 2. Now I'm ready to write down my LCM. For my LCM, I'm going to take the first denominator and I'm going to write the whole thing down. So I've got x and then x plus 2. Then I'm going to go to the second one and I'm going to write down anything that's not already written for the LCM. This says I need an x plus 2 and an x minus 2. I've already got an x plus 2, so all I need is the x minus 2. That's my LCM. So now when I come over to my fractions and write down what's missing, for this first fraction, I've got an x and an x plus 2. I still need an x minus 2. So that's what's going to go in the parentheses, top and bottom. For the second fraction, when I look to see what's missing, it's got an x plus 2 and an x minus 2. It just needs an x. So for the second one over here, I'm going to write x over x. So now if you look at the denominators, both of these denominators have the same 3 factors. So I'm going to write down my common denominator, which is x times x plus 2 times x minus 2. And then on the top, what I've got is 3 times the quantity x minus 2 plus 3x times x. So if I clean that up a little bit, I get 3x minus 6, because you're going to make sure you remember to do distributive. And then I have plus 3 times x, that's 3x squared. My denominator stays the same. Now it might look like I've finished, but let's come up here. I'm going to rearrange those terms. I have 3x squared plus 3x minus 6. I see there's a common factor of 3, so I probably better pull that out and see what's happening. So if I pull the 3 out of the numerator, I have 3 times the quantity x squared plus x minus 2, and I think that can be factored as well. So if I factor the numerator, I get x plus 2, x minus 1. When I factor the denominator, oh, that's already done. Great, I don't have to do it again. So it's already factored. Now take a look. I know it's clear down at the bottom of the screen. Let me move that up just a little bit. So when I get to this point, I'm going to need to look at the fact that I've got an x plus 2 and an x plus 2. So those are going to cancel, and my final answer is going to be 3 times the quantity x minus 1 over x times the quantity x minus 2. If you want to multiply those out, you can. You can also leave them factored. So let's take a look at this really briefly again. You put in what is necessary to get a common denominator, and then you do what it says on top. I have 3 times this quantity plus 3x times this. Clean up the numerator, get the terms in order. If you can factor it, factor it. I pulled out a 3, and then I did backwards FOIL, and lo and behold, I did end up with two things that I could cancel. The x plus 2 on the top with the x plus 2 on the bottom. And then you write down what's left, and you're done. Okay, let's look at this problem. The first thing I would recommend is that you get any binomial or trinomial in parentheses, so you're not tempted to cancel and you do your multiplication correctly. Now, my LCM, I'm going to write it over here, my LCM, the first fraction tells me I need an x plus 6. The second fraction tells me I need an x minus 3. So when I come over here and write them down, I'm going to write down what's missing, and I have to write the same thing top and bottom. Over for this one, I've got to put an x plus 6 over an x plus 6. Okay, now, this is a little bit interesting because not only do I have FOIL, but I have subtraction. So the denominator is now the same. So the denominator is x plus 6 times x minus 3. In the numerator, notice what I have here. I've got x minus 1 times x minus 3 minus x minus 7 x plus 6. Alright, so be very careful. When I do FOIL on this first part right here, I'm going to get x squared minus 4x plus 3. Okay, that's my first quantity. Now there's a minus here. So make sure that when you subtract a quantity, you subtract the entire quantity. When I do FOIL on this, I get x squared minus x minus 42. Now my denominator is the same, x plus 6 times x minus 3. Now what's really important here is that if it's subtraction, you need to make sure that you subtract all the way through here. So let's take this up here and see where we're at. Denominator is the same, x plus 6, x minus 3. Numerator becomes x squared minus 4x plus 3 minus x squared plus x plus 42. So when I put that all together, I have x squared minus x squared, that's 0. Negative 4x plus x, that's a negative 3x. A positive 3 plus a 42, that's plus 45. And my denominator is x plus 6 over x minus 3. Now I can pull out a 3 or even a negative 3 out of the top, and I get x minus 15. Denominator is the same. And it looks like there's nothing that I can cancel even if I do pull out the negative 3. So if that's the case, you can back up and circle this one as your answer, or you can just leave it factored like this for your answer. Okay, I want to show you this one because there's a little bit of a trick involved. Notice that these look the same except for the order of subtraction is different. Now the trick is when you have this kind of problem, the way that you fix that is you multiply by negative 1 over negative 1. So let's go over here and see why that's the case. If I take negative 1 times 2 minus x, let's see what happens. I get negative 2, and then a negative 1 times the negative x, that turns into plus x. Now if I put the plus x first and the minus 2 second, I get x minus 2. So multiplying subtraction by a negative 1 actually reverses the order of the subtraction. So over for this problem, all I have to do, now I've got a common denominator, because this is still 3 over x minus 2 minus, and now I've got a 5 times a negative 1, that's a negative 5, over this together turns into x minus 2. And then notice if you've got minus a negative, this turns into plus. And so my final answer is going to be 3 plus 5, which is 8 over x minus 2. All right, the last thing I want to do is look at complex fractions. If you have a complex fraction, you need to remember that this large fraction bar really just means division. So what this means is 4/7 divided by 5 over 21. And we know that to change division to multiplication, we multiply by the reciprocal of the 5 over 21. So when you divide by a fraction, you multiply by its reciprocal. So it's always this, whatever you're dividing by, that's what gets flipped upside down. And once you turn it to multiplication, you're welcome to do any canceling that you see. And so my answer for this problem would be 4 times 3, which is 12, over 1 times 5, which is 5. All right, so now let's look at one that's got some variables in it. And this one actually looks a kind of weird because there are 3 numbers instead of 4. Well, you know that whenever there's a denominator missing, you can put it over 1. So in this case, I've got x squared over y divided by 6 over 1. So instead of dividing by 6 over 1, I'm going to turn it into multiplication and multiply times 1 over 6. So I end up with x squared over 6y. Okay, let's look at another one. Okay, here's another complex fraction. I've got x plus 5 over x squared divided by 2x plus 10 over xy. So when you divide by a fraction, and we are dividing by this fraction, when you divide by a fraction, you multiply by its reciprocal. So here's my x plus 5 over x squared. Instead of dividing by this, I'm going to multiply by the reciprocal. Now this one needs a little bit of canceling. Now notice that I've got a 2x plus 10. I can factor that to 2 times the quantity x plus 5. So when I do that, I'm just going to draw a line through this. At the same time, I'm also going to put this in parentheses. It's always a good idea. So now look at the canceling that you can do. X plus 5 cancels the x plus 5. This x will cancel one of these, and I've just got x to the 1 left. So when I write down my final answer, in the numerator I've just got a y, and in the denominator I've got x times 2, or 2x. Okay, here's where it becomes a little bit tricky. If you look at this, in my denominator I don't have a single fraction, I've got the difference of 2 quantities. My rule says if I divide by a fraction, I multiply by its reciprocal, but this is not a single fraction, so I can't do that. So here's the first method I'm going to show you. What we're going to do is we're going to take this numerator and we're going to do a little bit of cloud work. So I'm going to write the 1 as 1 over 1 minus x squared over y squared. Okay, so my LCM for this small part of this problem here is 1y squared. It's just a y squared. So what I'm going to need to do is I'm going to need to multiply this first quantity by y squared over y squared. And what happens when I do that is I get y squared minus x squared over my common denominator, which is y squared. Okay, so I'm gonna just call this cloud work. So what I end up doing is this numerator, I worked with it until I got it down to a single fraction. Y squared minus x squared all over y squared. Now I'm going to do the same thing with the denominator. So this is a quantity. I'm going to do a little work on it. It's 1 over 1 minus x over y. So I'm going to need to find my common denominator. My LCM is 1 times y, or just y. So this guy is going to need a y over y. So what I end up getting for this one is y minus x over y. Okay, so I'm going to put a green cloud around that because that's cloud work as well. And so what happens is when I put those back into my complex fraction, I have this large division bar. Now I've got a single fraction over a single fraction. Now I'm allowed to change the division into multiplication. So here's my numerator. And instead of dividing by this fraction, I'm going to multiply by its reciprocal. Now it looks like I have a little bit of factoring to do. If you look at what I end up with, this guy can be factored into y minus x, y plus x, because it's a difference of squared. So I'm going to just cross that out and look at what I have left. This y will cancel one of these, and I've got one left. This y minus x will cancel this y minus x, and it looks like my final answer is going to be y plus x over y. So that whole messy fraction simplifies to a final answer of y plus x over y. Okay, here's a second method that you can use if you would like to. First of all, if there are numbers without denominators, give them a denominator. Okay, now look at all of your denominators. I've got a 1, a y squared, a 1, and a y. You need to write down the LCM of all 4 of those quantities. And the common denominator would be y times y, or y squared. So here's what we do. We're going to multiply the top fraction, the numerator and the denominator, by a quantity over itself. We've done that before. If I multiply by something over itself, I don't change the value, I just change what it looks like. I'm going to multiply the top and the bottom by my LCM over my LCM. So what that does, remember how distributive works? I would be multiplying it here and here and here and here. So instead of writing it like this, I'm going to write it a little bit differently. So instead of writing it out front as y squared over y squared and then drawing my arrows and multiplying using distributive, another alternative is just to write the y squared beside every single term in the numerator and the denominator. Because what happens then is I can cancel this y squared cancels this y squared, this y cancels this one, and I've just got a y left over. Then when you clean that all up, over here I've got y squared minus x squared, and there are no denominators. Here's my large division bar, and in the denominator I've got y squared minus x times y. Okay, so from that point, let's take a look at factoring. I've got y minus x times y plus x, because that's a difference of squares. And then in the denominator, it looks like I just have a common factor of y. So if I pull out the y, I've got y minus x. So it looks like I can do a little bit of canceling. This y minus x cancels this y minus x, and I get an answer of y plus x over y. That's the exact same answer we got when we did it the other way. So if I scroll back up here, this is the exact same answer. So you really have your choice. This method is the easiest to remember because we've already worked on how do you take a quantity, get a common denominator, and get them together on as a single fraction. So if you want to, you can treat the numerator separately than the denominator, get them both boiled down to single fractions, then turn the division into multiplication, factor, and cancel. So this one appears to be a little bit longer than this method. This is a little bit quicker, but the first method is really easier to remember. So it's totally up to you. You can use either method, but your answer needs to be totally simplified to a single fraction. Okay, I think that'll do it. We've added and subtracted rational expressions, and we've actually looked also at some complex fractions. So good luck.